Hello friends, welcome to my YouTube channel. So today we're gonna talk about the question which is rotate linked list. So what this question says? This question says that suppose we are having the linked list and it gives us the integer k. Suppose k is equal to 3. It means we have to rotate this linked list k times. So after rotating first time, second time, third time, we're gonna get the answer as this will become our answer. This will become our answer. So this question is available both in the lead code and the GFG. In GFG, it is said that we have to shift in the left direction. In lead code, it says we have to set the we have to shift the linked list in the right direction. But today, I am gonna tell you the approach which will work in both, and it will become very simple for you to understand this question. It will be very simple for you to understand the question. I have seen the many YouTube videos where the approach they have explained is very difficult. So today I'm going to explain a very simple example so you can understand. So before moving on towards the approach which I'm going to use, first I will tell you some basic cases which matters the most in this question. Suppose we have the linked list size. This is our given linked list, and suppose number of rotations required are 10. Number of rotations required are 10. So what will happen is that after 5 iterations we gonna get the same linked list. After 5 iterations or rotations, we can say it is a better approach. So after 5 rotations we gonna get the same linked list. Again after the 5 iterations we gonna get the same linked list, because this will move to this, this will move to this, this will move to this, this will move to this. Again we got the same linked list. So what can be our approach is that only suppose there are 13 rotations which is needed and the size of the linked list is length of the linked list is 5. It means only the three rotations that matters. So we will gonna take the mod will give us the remainder, means these 3 rotations will only matters, because 10 13 is equal to 5 plus 5 plus 3, means after 5 rotations we got the same, after 5 rotations we got the same. These 3 rotations will only matters. Now I'm going to explain you how it will all work. We have the linked list, and suppose k is given as 3. So what we have to do, we have to make these as the tail of this. These number of nodes, this is the part of the linked list which will become as joined as the tail here. So as you are now going to understand how it will work, this is our linked list. We gonna iterate over the k elements. Suppose this is our we make one pointer here, because we let's name this pointer the tail, because we should not change this pointer field, because this stores the address of this node. And this node will be joined at the end of this linked list. So suppose I have make one pointer tail here. It will messy. I have made the pointer tail here, and one pointer I am needing to move toward the kth node. So I will move to kth node. This is my kth node. Okay. Now here I am reaching. So we know that this linked list will become the tail of this. So this will gonna return our answer. This is our head ans node. I am giving the name. This is head ans node. So when we are going to return, we're going to return the head. This we will going to return, and this will join as a tail here. So our output will become 9 8 19 5 2 8. This will become our answer. So when we reach here, one thing which you are thinking that how we gonna link this to this, how we will reach here. So my approach is based on divide the linked list in 2 parts. divide the linked list in two parts. Like this is our given linked list. This is our given linked list. So what I will do is that I will separate this part of the linked list. This is our tail because this stores the address also. I will separate this part of the linked list, and this is I will point as a answer node. Now this part is separated. Now I will make one pointer here also named as pointer 2. I will iterate until this pointer become next equal to null. Means I will reach here. So once I will reach here, I will definitely gonna ptr2 next is equal to tail. Means this will gonna. Now one thing you are thinking that how this line will break. So actually what happens that when we will reach at the kth element, we gonna do one thing. Suppose kth element we have pointer name as ptr. Suppose we have the pointer name ptr in this kth element, kth node. So we will store, first we will get the answer node. So answer node, what will the answer node is ptr next. Answer node will be ptr next because we have to separate this part of the linked list, and then we will do the ptr next is equal to null. It means now it will point towards the null. This linked list separated, we have the address of the starting of this linked list. This linked list separated, we have the address of this also. A simple step we're gonna do is that we're gonna merge this. Means suppose we have the pointer here is ptr 2, we're gonna merge this. So how all it works is explained very well. So if I talk about the base cases, what can be the base cases? Base cases is here is that suppose we are having the linked list and k is given 0. K is given 0 means no rotation required. It means we're gonna return the same linked list. Else suppose one more thing is given, suppose head is equal to null. So then we're gonna return the head is equal to null, then we're gonna simply return the head. This is all about this. Now I will show you how the code will work. This is all about the code. So first we are this pointer basically for the iteration to go toward the kth node. This will remain the same to store the address of the first node because this will join at the end of the second half linked list. We have calculated the length and we have taken the mode. I have already explained you why we have taken the mode, because suppose there is 15 k is given 15 and length is 10. So only the 5 rotations matter, because in 15 we got that after 10 rotations linked list will remain the same. Only the 5 rotations that will matter. So we have taken the, now suppose n is equal to 0, it means we have the linked list size is 10 and we have k is equal to 10, we have to do the mode, the remainder will 0. It means no rotations required, so simply we will return the head. Now we will iterate over the linked list and we will reach to the kth node. And we will first make the next of the kth node as the unset, because that what we have to return. Now simply we have making the kth nodes next is equal to null, and so now we have to iterate in the second half of the node, second half of the linked list we have to iterate. That is, we have to iterate from the answer node to the end to reach the end, because in end only we're gonna add this tail one. This will add. So we're gonna now at the last we have merged the tail and return the unset. This all is done in the big of n time complexity. Thank you and subscribe my channel. I will come with another video, and if you have any suggestions please tell. Thank you.